Warmly welcome to our webinar. Today, webinar is about reduce, predict, and improve. First of all, can you hear me and can you see the presentation?
Yeah.
Yeah, we can see you and hear you.
Great, thank you. Very nice to see you there. Today, we will cover some examples of how to leverage simulation to diminish costly mistake, predict factory output, reduce time to market, decrease per unit production cost, and how to increase ROI. Nice to see that we have a good number of attendees joining and interested of our today's topic. I am Laura Mertanen, Events and Communication Manager at Visual Components, and supporting our speakers and experts today with this webinar. After I have quickly gone through the technicalities and how the webinar tool works, we will give the stage to our main speakers. They will then go through different customer cases, share their experiences and insights. And in the end, we have time reserved for questions. So please feel free to raise them throughout the whole webinar. Webinar is around 30 minutes lasting, so let's get started. Tool we are using today is called a GoToWebinar. All the attendees are muted by default. So you can raise the questions to the questions field, and we will go them through then in the end. This raise a hand functionality is not in use this time. Webinar is being recorded, so you are free to share the recording and also the presentation with your colleagues afterwards if you think they might be benefiting from it. And if you have any questions, you are warmly welcome also to contact us afterwards, so by email sales@visualcomponents.com. We have two very knowledgeable speakers today. So Reza Sankisi, he has been part of the simulation expert team since 2018, and he will be our technical specialist today. Through different international trade shows, for example, Reza is very used to working close to customers, knowing their cases and needs. And then we have Christer Eriksson. He is our sales manager for Sweden, Norway, and Iceland. Christer joined the company in 2013 and has been actually part of several of our offices, but now located in Sweden. Christer has a technical background, but is here to talk about the sales and customer cases. But without more talking, I will now give the stage to our first speaker. So Christer, please go ahead.
Thank you, Laura. Let's see if my screen pops up also. Do you see my screen?
Yes.
Yes. Okay, great. So, good morning to everyone. First, I would like to start with a quote from a customer, DHL. So, this is what George Walsh said. So, using visual components, we were able to achieve increased efficiency gains, reduced packaging and processing costs, whilst helping our customers visualize how automation could improve overall production efficiency gains. It's a game changer. But we will come back to the DHL case later on. First of all, let's talk about reduction of costly mistakes. I will just change a little bit here on my screen. Okay, so how can we reduce mistakes? So it's all about planning and conceptualization. And in our software or in simulation in general, it is quite easy to test different things. For example, if we're implementing mobile robots on the shop floor, how many do we actually need? Where should we place the charging stations? Will it be enough to have 2, or do we need 3? These are questions we can quite easily answer with simulation, but could be hard without. And especially it could be very expensive to make wrong assumptions there. Same thing goes with a robot. When you use a robot in a static CAD software, it is quite easy to figure out what is the reach of the robot, for example. But when you add a gripper to the robot, it could be a challenge. So what happens if I now add this kind of gripper? Do I get more reach in the direction that I need it, or do I actually get less?
Good morning to you, Chris, and good morning to our audience. One question that I was wondering about here is that you just talked about having the reachability. What if you have the gripper there and then you have your type of robot, but you don't reach that reachability? Then what would you do?
Good question, Reza. So basically, if we talk more about our software, so Visual Components platform, we have this large library of components. And in the library, by default, you will find over 70 different grippers. So you could simply try with another one and see what happens. Do I get now the reach that I need? Does it change the reach in the direction that I need it? Yes or no? If no, okay, let's try another one. And we can kind of narrow the problem down towards a solution that would fit our requirements.
I see. Okay. So in case there is also some customized model of gripper, you can also use that one, right? If a customer has their own type of gripper. Yeah.
Sure. I mean, you can import almost any kind of CAD data. So just drag and drop, kinematicize, and there you go. Now you have a functioning gripper.
Got it.
Excellent. But let's move over to predicting factory output. So this could actually be a true challenge when you are not simulating anything. You're making up your simulation in your head, or you're using Excel sheets, or you're simply stuck in your 2D, 3D static world in CAD.
So I mean, now, Chris, in this model that you are showing us now, what kind of information or what kind of outputs do we get from such a model?
Well, basically, this is the beauty. You could study any kind of numerical data. So what we see on the screen right now is quite a lot of different data coming together and being presented to me as a user in a nice way. So we have, for example, the utilization of the robots, the utilization of the machines. We have the walking distance of the operator. And kind of, we also see in the top left corner here now the buffer level. So how many products are available for the robot to pick? And when we combine the data with the visual stimuli we get from the 3D world, we can start to draw our conclusions. So we can clearly see by looking at the utilization of the robot compared to the utilization of the machines that something is terribly wrong with this cell. I mean, the machines are, let's see here, we look at the pink slice of the pie chart, 20% utilization, 10% utilization, 10% utilization. This is not what we want to see. We want the machines to run all the time. So what can we do differently? Well, for example, in this case, we can see the robot has only a single gripper. So what happens if we would like to implement a double gripper? Would we now reach the output that we need from our cell? If not, okay, what else can we do? Okay, we could try to split the cell into multiple, maybe having 2 robots or 3 robots to serve the machines to see if we can hit our target, reach the output that we need from the cell. And this is how we can predict the factory output utilizing simulation. This is a quote from another customer called Firak, and they were talking about their customer. So the customer was really impressed with the visual implementation of the process. And that's how Firak got the competitive edge to win this project, according to Quarantine. I'm not sure about the surname here, but I guess it would be Monod or something in this direction. So what is this project all about? So we had this manual production cell or station at the PSA group. And The job here at this station was to tighten some M6 and M8 bolts to this assembly. And the process spanned over 4 shifts. And during these 4 shifts, you have many different operators there. And because the operators have different skill levels, of course, you will also see variations in cycle time. And when you get these variations and fluctuations in cycle time, it makes it hard for this sub-assembly to stay in line with the main assembly. The main assembly cycle time is supposed to be 60 seconds. So if we get a higher cycle time than 60, we have a large problem.
So here, Chris, what kind of requirements PSA Group had on this design?
Yeah, so basically they wanted to get away from these deviations in cycle time, right? So they wanted to have a new cell that would have a cycle time less than 60 seconds. They also wanted the cycle time to be stable, and they wanted the final solution to be that it should be possible to implement it on the shop floor. And what is cool in this video is that we actually get to follow the whole process. So from the first ideas, trying to iterate towards the correct solution or a good solution, trying 1 robot, 2 robots, that the robots are facing on the opposite side of the assembly so that they can work in the same time, and these kind of things.
So this is pretty like detailed simulation. And I look at your video. How long did this take? I mean, how long did pre-study part take for them?
Yeah, according to FIRAC, they spent less than 2 weeks on the pre-study of this project. So before they won it, and not all of that time was even spent in simulation. And by the way, right now you can see how this looked like when it was implemented in the real factory on the shop floor. So pretty cool stuff, I would say.
Yeah, and this cool stuff that you are showing, then I was wondering what was next. Like after winning the project, did they still use simulation, or simulation was still engaged in the, I don't know, in the commissioning part, in the parts after having the design ready?
So they said that they were continuing to using visual components throughout the project, and they mainly used visual components to validate the mechanical design, ensure the accessibility of the robots, for example, proper clearance, but also checking how we can implement the cell in the factory. And the solution itself was implemented within 6 months, with FIRAC then spending a couple of months on site to fully test and integrate the solution on the shop floor.
Great, got it. Thank you.
How about reducing time to market? Is that something we can do? Yeah, possibly. So for example, utilizing simulation, you can avoid or at least minimize or try to minimize dry runs, meaning that you run your factory lines empty, you have dummy products and whatnot. And that, of course, dry runs takes time, it takes money. So if we can reduce it, it is very good.
Yeah, here when I see your video, Chris, I also remember that once I was visiting a factory that they had a purpose to reduce these operator times that was spent on individual workstations, and there to reduce this time spent by operators, they had these huge Excel sheets with lots of calculations and formulas behind, and that was really time consuming. Here, when you're showing this, I'm also wondering, can simulation help with this case that I just mentioned?
Yes, I would say so. This is kind of the perfect use case for simulation. So we have a bunch of operators, we have our factory. Now, where should we place the material? Where should the storage racks be? Where do we put the stations? Because what we want to minimize is operators walking around with or without material or product. So we want to decrease the walking distance, right? So we get the spaghetti diagram of the operators, we check the walking distance. Okay, what happens if we move the materials storage closer to this cell? Did it get now further away from something else? How can we subdivide it? And then by going back to the statistics dashboard we were looking at before, we can check the output of the factory. Did it improve or did it get worse? And what happens now with the walking distance and all this kind of wasteful activity that goes on in a factory? So yeah, I would say so.
Yeah, now that I think about it, it's similar to that output slide that you had earlier. Yeah, are there some other type of similar approaches that could be replaced by simulation?
Yeah, so this kind of fun thing you see on the screen right now.
Yeah.
So this cartoon box simulations. So this is actually something companies still do in 2021. So they bring in the operators, all the staff, and they let them walk around on the shop floor or in some made up shop floor with boxes and make time studies and see how long time did this take, did we get this and this there, and so on. And I would say that it's quite wasteful. It's a waste of time and it's waste of money. This is clearly something we can simulate instead.
Yeah, and in
um,
simulation, you don't have to pay individually these guys and then also get them lunch and stuff. So
True
very
that,
true.
true that. And of course, we could try to minimize this kind of Excel World Championships you were talking about before. So having this huge data sheets with all kinds of information and tweaks and try to get some information out of that, just simulate instead and you will be all right.
Roger that.
Now about DHL, I think you had some input here, Reza.
Yeah. Here, I wanted also to mention about the per unit production cost and decreasing it. So you might already have some idea about this, but let me maybe share some insight about DHL, which is the world's leading logistics company. I'm not sure if you have used their services.
Sure, many times, yeah.
Yeah, so me too. And but it was interesting case for me because it's a company that I've known for maybe a decade and a half. But then it was surprising that I found they also have challenges. And apparently their industry is working with many different sectors. I don't know, you name it, health, pharmaceutical, with automotive, they are working with financial services, with food and beverages, etc., etc. So they require a high level of customization that actually it also requires a high degree of technical control, to keep the efficiency and the outputs accurate. And we also got to know that it's important to them to show to their customers the solution they are preparing. So in this case, they want to show that they can actually reach the efficiency that the customer wants and also the cost reduction and increase in the production.
And why did they choose simulation for this?
Well, it's a constantly changing line of work, and it's really, especially in this year with the corona and everything, and there is the highly competitive world now. So they started to have simulation for building their models much faster than before. And as you can see also now in the video, they could do equipment verification after building those models, and then they did warehouse planning to actually optimize their processes.
Yeah, what else?
So those equipments that they built or modeled in the simulation, then they made extensive libraries out of those. And when DHL was getting more projects, then they already had those models ready. So that made it like quite modular. So they were able to use those already prepared models and make this kind of, like the pre-study work with Furac that you showed. Now they have quite an extensive library. So these new projects that they get, they can much faster create these concepts and send it to customers, show it to them. And of course, showing these will be with these high quality graphics, as you can see a sample now in front of you. And well, that made the stakeholders quite happy because they could actually interact with them and also see what's the progress in the pre-study part.
So you mean that they spend some time upfront to create this component library, and then after that they can win time back and basically a multiple?
Exactly. Yes.
Cool. Were there any other outcomes from this?
So when we go to what they got out of it, and for example, for the health industry packaging system, they started to have these individual workstations and change it to a balanced flow line, So they could, with that, increase the processing efficiency. And then with the electronic goods packaging, this is exactly the case that now you see in front of you. They could increase the productivity, while actually they kept the costs, the maintaining costs, and the productivity was increased by almost 1/3 thanks to simulation. And yeah, as a result, also they got to have a visual communication. They could show that how their solution impacts the whole design phase and how the proposed changes are working. Then they would actually also improve the floor plan layout. So the floor plan was reduced by 1/3, and while they actually kept the efficiency. And then there was identifying the some issues in advance. So without sacrificing any output or quality or flow, they could already understand that there will be a bottleneck here, as you also mentioned earlier, Chris, in what like one of the obvious benefits of the simulation. And
so
last,
this sounds like a real positive thing. You're able to find problems before they happen. This, of course,
yep,
makes it hard to measure. Like if you have fixed the problem before it happened, then maybe your boss won't see that. But in the end of the day, you know that you saved money on this. And you also mentioned that they were able to decrease the footprint of the whole cell and also increase the performance of the cell in the same time. And
very
all
true.
thanks to simulation. Yeah, cool.
Yeah, exactly. I mean, they don't have to move to any hardware yet, but just in the simulation, in one PC, they can run all this, and they can also run multiple scenarios. So they choose out of those scenarios the best one. And here, for example, in the project that you see now, they were able to run scenarios with using robots or with using human workers, or then maybe by using both. So they got like kind of an ideal case. They kind of found that, okay, this is the way we should do it. This level of automation and this level of manual work is perfect for us. So they actually, yeah. So this
cool.
operation interaction was improved quite a bit.
And also in this video, you can see statistical data being presented in some different ways. For example, on the screen here, we can see the utilization of the different robot cells. And on the wall, we see, for example, the cycle time of the cell. And then there was also this little information dashboard where we could see different kind of data running in the simulation, this white one. So utilization, parts produced, and so on. So it makes it quite powerful as a communication tool.
Yeah, also in one of the projects, I'm not sure if it was maybe for other customer. The customer at the end actually put these graphs that are like real time connected to the simulation, but on a huge screen in the factory floor. So workers actually could see during the day that what's going on and how they've been doing, because the data from the simulation was connected to the factory at the same time.
Cool.
Yeah, that was, yeah. So you had something about the increasing of ROI of media, I guess, Chris, right?
Yeah, correct. So how about increasing ROI? So that is something we all want to do, right? Return on investment. So when we look at this big factory here from IDEA, this is, let's say, on the large side of a simulation model. So what happened here? So according to Kong Fanshi, the simulation engineer at the digital center team at Media Group, utilizing simulation here, they will able to reduce the floor space by 10% of this whole layout. So that's quite a lot since it's a big factory, but in the same time increasing production capacity. So we are decreasing the space required and at the same time increasing our capacity. And this is then from the original idea, right? And in the same time as these two, we were able to increase the product quality. So coming down from 1,200 defects per million to 120 defects per million. That's a 90% cut. And that is not all. According to the same guy, they were able to reduce the construction time of this factory from 15 to 12 weeks. So that means 3 weeks of labor costs and, I don't know, cranes, whatever equipment you need to put together this kind of factory, you were able to save.
Chris, these numbers that you are mentioning about the capacity, the product quality, and construction weeks being reduced, I mean, they are huge. What was the estimate? What was the estimate that they had in terms of cost saving for this project at the end?
Yeah, so that's the kind of nice thing about this case study here. So we actually have some numbers. So they are estimating that the total cost of the project was reduced with 15%, and that amounts to $879,000. So close to $1 million. They are estimating that they were saving on this project alone by utilizing simulation. And yeah, I mean, that is just fantastic numbers.
Yeah, what you are mentioning is really a big deal. I mean, thinking about the cost they had to put on the simulation and what they got back, it is really astonishing.
Yeah, I agree. Yeah. So now we have come down to the Q&A session. So if you have any more or further questions, please just type away and we will try to answer them. Let's see. And of course, questions about offers and quotes, we will take individually with all the attendees afterwards. Otherwise, if there are no other questions, then I would like to hand the screen over to Laura again.
Thank you. I will start sharing my screen. Just a second. And can you see my screen now?
Yes, we can.
Thank you. Thank you, Reza and Krister. This was really interesting, excellent discussion and examples. So as mentioned earlier in the beginning of the webinar, we are recording this and all the material will be shared with you. So around in a week you will get also the recording. So feel free to go back to that if there's anything interesting. You can also follow us in social media. So we have quite a lot of interesting content coming up regularly. So that's the place where to find more information. And of course, afterwards, if there are any questions, you are more than welcome to contact us also by email. But yes, I would like to thank you all for joining. Thank you, Krister and Reza, for excellent presentations, and have a nice day to everybody.
Thank you, Laura, and thank you, Reza.
Thank you, Laura.
Thank you all for coming.
Thank you.
Yes. Sorry. Have a nice day. Cheers.
Cheers. Bye.
Bye.
Bye.